Today we will be discussing limiting and excess reagents. As we look at this title, we can see the word limiting, which you should know kind of means we are limited by it. It's going to be our reagent shortfall. It's the one that we don't have enough of. And excess, as in excessive, we have too much of this reagent, and that will be the one that we have too much of versus one that we have not enough of. The word reagent is going to be another word for reactant. Okay, so my reagents are my reactants, and I'm going to be figuring out which I have not enough of and which I have way too much of. So my limiting and my excess reagents. Generally, when we're performing an experiment, we are not particularly concerned about making sure that we have the exact right proportion of every single compound. We are just worried about kind of getting the reaction to happen in the first place. So since we don't normally have the exact correct amount of each of my possible reagents, we need to check which one I am going to have as my limiting and which I'm going to have as my excess, because that will determine what I can reasonably expect to come out of my actual reaction. So I have this balanced chemical equation here right now. Go ahead and ignore the connections. I have done it before the actual need for them has arisen. Okay. So we have this example problem. It states if you were to react 18 grams of hydrochloric acid, HCl, with 18 grams of sodium hydroxide, how many grams of sodium chloride would be produced? Okay, so with this, I am seeing 3 different compounds. I'm seeing hydrochloric acid, I'm seeing sodium hydroxide, and I am also seeing sodium chloride. 2 of them, the HCl and the NaOH, are on my reactants side, so those are my reagents. And my sodium chloride is a product, so I'm trying to figure out between HCl and NaOH, which of the 2 that I have weighed out the same amount in is going to limit my amount of product that I'm actually able to create. On first glance, it might look like it's going to be the same no matter what because my masses are the same. This is not true, however. Remember that the molar mass for hydrochloric acid and the molar mass for sodium hydroxide are different, and therefore my numbers are going to be different. So you can choose which of the 2 reagents you would like to start with first, and you're going to set up the gram to gram conversion for each reagent, just like we have done before, and you're going to try to figure out what your amount of your desired product is going to be. In this particular example, I have told you which product I am interested in, sodium chloride. This doesn't happen all the time though. If I'm just asking for a limiting or an excess reagent and I do not provide a desired product, you get to pick which product you're going to look for, but you have to remain consistent. If you calculate how much sodium chloride you get for one compound, you can't switch and calculate how much water you're going to get with the other compound. Those are not the same thing, and you cannot do a direct comparison. So the very first thing I did was I went ahead and set up the gram to gram conversion for sodium chloride and hydrochloric acid. So as you can see here, this is in blue text, and that was my blue connection. And I went ahead and stated that I was looking for grams of sodium chloride produced using 18 grams of hydrochloric acid. Then I used the molar mass of hydrochloric acid, then I used the mole-to-mole conversion between the 2, and then I used the molar mass of sodium chloride. This 3-step conversion factor setup should not be new to you, and you should have been very comfortable writing this out. The only new thing is the comparison and actually establishing who is my limiting and who is my excess, but nothing in this actual process is any different than anything that we've done before. So we did all of this, and the number that I got out of the calculator after I typed in 18 times 1 times 1 times 58.44 divided by 36.46, 1 and 1, The number that I got was 28.85134394. I went ahead and I rounded it to the second decimal place, and then I attached the appropriate unit, which was grams of sodium chloride. Now I have one of my two masses that I need to be able to do this comparison. I found the grams of sodium chloride from that could have possibly been produced from my 18 grams of hydrochloric acid. However, I am not done because I don't know how much I could have produced using 18 grams of sodium hydroxide. So that's the next thing that I'm going to do. And so I went ahead and established the gram to gram conversion for sodium hydroxide and sodium chloride. So same things kind of going on here. I have my 18 grams of sodium hydroxide that was established inside of the problem. I have the molar mass of sodium hydroxide, which as you can see is different than the mass of hydrochloric acid. Then I have my multimole conversion, and then I have my molar mass of sodium chloride. Grams sodium hydroxide cancel, moles of sodium hydroxide cancel, and moles of sodium chloride cancel, leaving me with grams of sodium chloride, which was the unit that I said that I wanted. So I could go ahead and type out 18 times 1 times 1 times 58.44 divided by 39.997, 1 and 1. When I did that, I got the number 26.2999725. I rounded it to the second decimal place, and that gave me 26.30 grams, and I attached the unit sodium chloride. Now, both of these, I am now going to compare my expected yields. Yield is the word of my produced product, and I'm going to compare how much I could have possibly gotten when I reacted 18 grams of hydrochloric acid versus how much I could have possibly gotten when I reacted 18 grams of sodium hydroxide. When I do that, I see that the 26.30 grams of sodium chloride from I kept it color-coded so I would be able to keep it straight in my mind. This is my mass that could have been produced from sodium hydroxide. This is my mass that could have been produced from the hydrochloric acid. When I compare those, I am going to establish that the product that is smallest is going to be from my limiting reagent. So since 26.30 grams of sodium chloride is smaller than 28.85 grams of sodium chloride, that means that the reagent that was responsible for this number, which was sodium hydroxide, is my limiting reagent because I didn't have enough. And the 28.85 grams of sodium chloride, the reagent that was responsible for that number, is my reagent in excess. We are limited by my limiting reagent, which means that I can only ever expect to produce at most 26.30 grams of sodium chloride because I do not have enough of the sodium hydroxide to produce anything more.